people would define themselves as being from a business side, just by a show of hands. You're a business person, you come from that side of things. Okay. How many people would define themselves as a technical person? You're coming from maybe the developer side or computer science. Okay, and then how many would you say you're academic, maybe in nature, you're faculty or something, and then just other? You're a community member, photographer, myself. Cool. So I thought that tonight it would actually be really good because in a lot of the meetups that we get in blockchain, we have some really technical ones where when you go to them, they're insanely detailed and coding. And for myself, where I'm more of a business person, or like I go to these and I don't understand much. But at the same time, I still actually really appreciate seeing what's going on at the coding level. Even though I don't understand maybe every little detail, I actually really like just following along as much as I can and understanding the general concept and even just having some insight into what the coders are doing and the challenges that they face. So one of the things I was hoping with this presentation is that even for the business side of the room tonight, you might appreciate seeing some of this, what the developers are dealing with and just how technical it is and kind of the angles of thinking that they come from. And you might see some value. You may not understand 100% of what they're saying. It might seem a little in-depth at times, but I hope that at some point, this just gives you some insight into that world. And if you continue in blockchain in the business space, at least you've looked at coding a smart contract and what that's about. And then more importantly, or not more importantly, but just as important is the security of a smart contract. So and a blockchain we know is very secure, but coding a smart contract is not necessarily. A human is still coding it, and humans might still be auditing it. It is a point of failure, so we need to secure that if we want this technology to succeed. So in that, we have Martin Derka, who is our senior research engineer at Constant. He's one of our best auditors, very distinguished and awarded, intelligent person, and he is looking at everybody's code and he knows everybody's secrets. So without further ado, here's Martin telling you how to be secure with a smart contract.
All right, first question. If I stand like here and I have my hands on the keyboard, not holding, do I need to?
There you go.
Yeah, there you go. How was that? Better? Yes, perfect. All right, thank you, David. I appreciate the introduction. So I'm Martin. And I like starting my talks with questions. June 17, 2017. Anybody here remembers what you were doing that day? I see 0 hands. I actually know some people in the audience. Daniela, what were you doing June 17, 2017?
Can I get your copy?
Doesn't know. Matthew.
I get a copy.
Sean. David? Where's David? He just escaped.
Okay.
Oh, there he is. He doesn't pay attention.
Ah.
All right. So, since you do not know, that actually tells me that you did not invest into something that is called the DAO. Because if you did, you would be crying on that day, and you would know right now that you were crying on that day. Because on June 17, 2017, the DAO, whatever it was, we'll tell you in a second, it got hacked. And the hackers stole 150 million worth of Ether from DAO. So the DAO aimed to be something that is best described as a venture capital fund for technology projects, but it was supposed to be a special decentralized venture capital fund. So they wanted to have a smart contract that would be holding lots of Ether or money, and the investors themselves would decide which projects would be funded and which projects would not be funded. And they started doing their token sale, and they had that smart contract, and the smart contract had lots of Ether worth lots of money, and that smart contract got hacked. Okay? So what I'm going to do today, I'm going to actually show you using the smart contract that Nilo implemented or showed you how to implement. I'm going to show you how the DAO hack actually worked. And the DAO hack was based on something that in theory is called reentrancy. So I'm going to show you in practice the concept of reentrancy, which some people might say is now the scariest thing that is actually present in blockchain. So from theoretical perspective in computer science, if we say that a method is reentrant, it means that the execution of that method can be stopped halfway through, and the method can be started again, so-called re-entered, without actually breaking anything. It can finish, and then the original execution can finish, and everything will be just handy-dandy fine. Okay? So this is what re-entrant means. Now, I'm actually showing to you what it means on blockchain. So first of all, you should already see, or you should already know what this screen is. This is Remix. This is our IDE. And I have the very same code that Milo showed you, and that's my escrow contract. Yeah? So it exists in here. I did some tweaks with it, but I will not talk about those things yet. I will show them to you in a second. I want to start somewhere here. What Milo did not show to you is that Remix actually allows us to deploy this smart contract on blockchain. It actually allows me to run my personal copy of blockchain on my own laptop, and it allows me to execute all of this. And I will actually start with that. I will show you how this contract is supposed to work in practice, and then I will do something nasty there. Okay? So here in Remix, we have 5 wallets, 5 artificial wallets. They exist only here on my laptop, nowhere in the internet. Okay? So those are 5 addresses that allow me to create transactions with them. Down here, I have a little box that allows me to create an instance of this contract on the blockchain, and then below here we will see what I will have. So how this thing is supposed to work is as follows. I will be right now representing a seller, and I will deploy this escrow contract on my local blockchain. Okay? So I'm going to grab this account, this 0xCA3, that's my seller's account. Okay? I'm going to click this button to copy it, and I'm going to unwrap this little box that provides me with an interface for entering the constructor parameters. So this is my address as a seller. Okay? Now I'm going to switch into the other one, 0x147, that's going to be the buyer. So I'm going to plop this in here. I'm the buyer, okay? And the price of a house, how much would be the price of a house?
1 million.
Yeah, a lot, okay. I will say 1 ether, okay? Because, I have only 100 ethers in my wallets. So price of a house is 1 ether. I will now swap back into my seller's account, and I will click transact. That means that the seller is deploying this particular contract on blockchain. So I will hit transact. If I unwrap this console, lacking real estate in here. Let's see. Okay, we will actually see it here. We will see deployed contracts, so that actually shows me all the contracts that exist in my local copy of the blockchain, and it tells me that right now I have created escrow, and it has some address assigned to it. Everything that exists on the blockchain has addresses assigned to it. It's my wallets, it's contracts, it's everything, okay? So escrow exists, and Remix gives me this OK interface to check various variables that are preserved in this contract. So it allows me to ask, who the hell is buyer? And if I click it, it will show me 0x147 and lots of other characters, and that's the buyer. That's the address that I provided to it. And I can ask that thing, who is the seller? And because it's stored in there, it will tell me who is the seller. And I have those Boolean variables. So is buyer in yet? No, it's not in yet. Is seller in yet? No, it's not in yet. Okay? So this is the state of the brand new contract. So Milo told you that we need 3 steps. We first need to initiate the contract, then the seller needs to pay in the money, and then the then the buyer needs to pay in the money, and then the buyer confirms that the item was delivered, the house was delivered, and then everything gets released to all the wallets. Okay? So let's do that. So first of all, I am 0xCA3. Me, that's the seller. I will say that I will transfer 1 Ether because that's our agreed price to this contract. So I hit 1 here, and then I go down and I click Initiate Contract. That means that me as seller from my own wallet, I'm transferring 1 Ether to this contract and I'm initiating it. So I click the button, and after clicking the button, I've already done it. If I click here, I will see that seller is suddenly in because that method was executed on the blockchain. And my contract has a new state. Okay? What I will do next is, on behalf of the buyer, that's this guy, I will also agree that our price was 1 Ether. So I will stake my own 1 Ether into it, swap the wallet. I entered 1 as the value, and I will click Initiate Contract. Okay, here, clicked. If I now check whether the buyer is in, yes, the buyer is in. Okay, so we have both people in. Step 1 is done. Nilo told you about those states in here, so I can actually check the state of the contract. So here, if I click current state, I will see that the current state is 1. What is happening in the background, those words in here, they are actually being translated into numbers. This is number 0, this is number 1, this is number 2, this is number 3. Okay? So right now, my contract is awaiting payment. That's the state 1. So done with step 1. So the second step is for the buyer to transfer some money into it, and that's the payment itself. So on behalf of the buyer, it's my second account in here, and I'm going to say that I am transferring 1 Ether in it, and I'm going to scroll down, and I will confirm payment. Okay? Clicking here. If I scroll up, you can see that 1 Ether disappeared from this wallet. Before it had 98 plus something, now it has 97 plus something. And if we check the state, we will see that this current state will have changed into 2. I'm clicking it now. It changed into 2. Okay? Step 2 is done. So the last piece that is supposed to happen, the buyer, 0x147, is supposed to call confirm delivery, and at that moment, the smart contract will transfer all the Ether that belongs to the buyer back to the buyer. That's the stake only. The seller will receive the stake and the selling price, and everything will be done. Okay, so I'm clicking confirm delivery. Done. And if I scroll up, I will see that me, as the seller, I am at 100 Ether plus nearly 1. That's how much I wanted to get. As a buyer, I am roughly 1 Ether poorer because I transferred something to the seller. And if I scroll down and click on the state, it's here. My state completed into state number 3, which is complete. Okay? So this is the escrow, and this is how it was supposed to work and how it is supposed to work. Okay? All good there. So Nilo showed you the code, and I actually fixed up that code a little bit, in a very, very subtle ways. So let me show you what I've done here and what is a little bit different. So without going a little bit too technical, I added 2 functions. I added function load, which is payable, and it's simply a convenience function to battle some limitations of Remix. But for the rest of this talk, we will actually be pretending that this smart contract is part of much larger system, something like the DAO that collects lots of Ether from various entities, and that this smart contract can actually hold lots and lots of Ether. Okay? And for me to be able to achieve that in Remix, I implemented an empty function load so that I can transfer something to that smart contract and it can keep it. Okay? The next one is a convenience method. It's called getBalance, and it's again to battle some limitations of Remix in here, but this method exists only so that I have that one button that allows me to click it, and it will tell me how much Ether that smart contract holds. Okay? And then I made one more change, and that change is right here. So if you check Nilo's code, she had the method that would transfer some ether to the buyer. They would get back their stake. And then she had the other method that would transfer some ether to the seller. They would get back the stake plus the selling price. So I replaced those methods. Nilo was using transfer. I replaced those methods with .call, .value. In Solidity, we have 3 ways of transferring ether between contracts. They have some very subtle nuances in which they differ. So instead of whatever Nilo showed, I decided to do something different in here. Okay? Otherwise, the contract remains exactly the same. So what I'm going to do here, I'm actually going to compile the contract that will reset my local blockchain. Just compile, I believe. No. There we go. Just compiled. It reset everything. Again, I'm going to erase all the deployed contracts. So now my blockchain is empty. I have 5 wallets. All of them have 100 ether. Everything is as it was at the beginning. Okay. So let's start. I'm the seller. My wallet is 0xCA3, and we said that the first thing that we need to do is deploy the contract. And for that, I have to talk to the buyer and I have to get their wallet address, right? Because I have to fill that thing in here. Okay. Now, as a buyer, I actually want to be a little bit tricky. So, developers often make this assumption that their smart contracts on blockchain will be interacted directly with from people's wallets. But that's actually not the case. As Nilo told you, blockchain is its own autonomous thing. So there might be smart contracts interacting with other smart contracts. So if you deploy your own smart contract, the transactions can actually come from some other smart contract, and they can be just forwarded to you. Okay? So me as a buyer, because I want to scam this a little, this is exactly what I will be doing. And I will show you that code in a second. So I implemented one more contract. It's called proxy, because I will be using it as proxy to forward the calls to the escrow contract. Okay? So this proxy contract remembers who is the owner of it. That's me, the buyer. It has the constructor that remembers the owner, remembers the address. And then it has 3 methods. Call initiate contract, and it just accepts an address and it forwards that call to that address. And then it has another method, call confirm payment. It accepts an address as a parameter and it forwards that call. And it has another one, confirm delivery, and it does the same thing. It accepts the address and forwards that call. Okay, so it's true proxy. Then for convenience, again, I have to get balance so that I can show you how much ether this particular proxy contract holds. And because I want to use it for my own benefit, I want this contract to earn some ether and then I want to withdraw it, I actually have a withdraw method which first checks whether my withdrawal attempt is actually coming from the owner. If it doesn't, then it will throw an exception and revert state. If it does, then it will send me all the ether that exists on this contract. And that's what I want. And then I have this weird function, actually going to come here, which is a real gotcha in Solidity. So in Solidity and Ethereum, there is this one weird function that is called the default fallback, or the nameless function. And it's an evil function that gets executed every single time you send an ether into a smart contract. And majority of legit smart contracts have this function empty or doing some innocent stuff. Me as a developer, I actually decided to do something different. I decided to put a recursive call to the very first contract into this empty fallback. And this is the piece keys that will start allowing me to earn some more ether that normally should not belong to you. So I will later show you a slide about what is happening, and that will make it all clear. So let's play with this. Again, I will now start as the buyer, 0x147, and before doing anything, I'm going to deploy my proxy contract to the blockchain. So I will say, I will flip this, and I will say that I'm deploying proxy. Okay, deploy. If I look at my contracts in here, my local blockchain, Ethereum, right now contains my proxy contract, and it has some address assigned to it. Okay. So when my naive seller comes and asks me for my Ethereum address, I just give them the address of the proxy, because that will be representing me, right? So I copy it to my clipboard right now. I will switch into escrow. I will switch into my seller's wallet. I will drop this down, and the seller just came and asked me, hey buyer, what is your wallet address? So I gave them address of my proxy, because that's representing me. Then the second thing, I'm grabbing the seller's address and putting it in place of seller. And again, we have to agree on a price. Price will be 1 ether. Okay? Deploying on behalf of the seller from seller's wallet 0xCA3. Transact. If I go down, I can now see that I have 2 smart contracts deployed on my local blockchain. One is the proxy, one is escrow. Okay? Here I can see the same suite of method, confirm delivery, confirm payment, and all those things. So buyer is not in, seller is not in, but I know who the buyer is, I know who the seller is, we know the price is 1 ether. I have a bunch of zeros here. Those zeros, you can freely ignore them. The same way how fiat currencies, we have dollars and we have cents. Ethers, they also have fractional units, so this price is just reported in those fractional units, and there happens to be 18 zeros there. Okay? But this is 1 ether, actually. So that's my escrow. It's ready for those 3 steps to be performed. My proxy allows for the fallback being called, the couple methods, and then get balance and my owner. Okay? Everything that I implemented. So I said that we will be pretending that this system is part of something much, much, much bigger, and it can be collecting more ether from other people. So I had that method, load. So I'm going to load this smart contract with much more ether, okay, from the seller's pocket. So I'm going to transfer 95 ether to it. So I'm hitting 95 as value and hitting load. If I do that, the transaction went through. You can see that poor seller right now has only roughly 5 ether, less than 5 ether in their wallet. And if I check the balance of the smart contract, the balance is 95. Okay? So it holds some ether. And now I will start doing the magic. So we said that we are the seller and we need to first initiate a contract. So we need to send the agreed upon value to it. That's 1 ether. I'm going to do that and I'm going to hit initiate contract. Okay, that's the seller. Boom. Seller is in, turned into true. Now I have to do the same thing for the buyer. So I will switch my wallet into buyer. Still have nearly 100 ether. I enter 1 in here. Okay. But now instead of sending this into the escrow contract directly, I will send it to my proxy and proxy will forward it. Okay? So I will be calling this call initiate contract method, to which I just need to provide the address of the escrow contract. So I'm hitting the button, the transaction happened, and suddenly the buyer is in. Okay? And if I check the balance, there will be 1 extra ether for the seller and 1 extra ether for the buyer, so 97. Okay? So step 1 is done. Now I need to do step 2. I need to confirm payment. So again, from the buyer's account, I'm going to enter 1 ether here, And I'm going to confirm payment for the escrow account through my proxy. So I'm grabbing the address, I'm throwing it into confirm payment, and I'm clicking the button. That got forwarded. So my balance will be 98 Ether, and if I check the status, this will be number 2, expecting confirmation of delivery. So right now, again, from the buyer's account, I will call confirm delivery. I will copy the address. I will call it through the escrow, and I will just, before I do that, I will do one more thing. I will actually click get balance. You can see that proxy right now does not hold any Ether. Okay? So just to double check, we'll do that. So I have my address in here, and I will start confirming delivery. I will click confirm delivery, and now my computer will be crunching for a moment because it's actually computing a lot, but at some point it will finish. Let me just double check that it did finish. My transaction did not go through. Let me check that again. So from my I have buyer in, I have seller in, I have balance, which is big, and I have staked, and staked is 2, good. So again, what I need to do, I need to have my wallet set correctly, I need to have my address set correctly, and I will call confirm delivery and click confirm delivery here. In here, there we go. My call is now happening and my computer is calculating. I don't know what went wrong a second ago. This always happens. So let me tell you what is now happening. Oh, we can see that it went through. So what is now happening? What is happening is this. We'll switch back to my slides because I have a graphical illustration to share or present. So what is happening is this. I used my proxy to call confirm delivery on the smart contract, on the escrow. The escrow contract transferred Ether to buyer, which inevitably triggered the call on the fallback. And the fallback call, because I put that malicious call, it triggered another confirmation of delivery without the status of the contract being changed, without anything happening to it, which gave me a little bit more Ether, and inevitably it triggered another fallback call, which gave me a little bit more Ether, because it triggered another confirmed delivery, that gave me Ether, that triggered fallback call, and then it went on, and it went on, and it went on. So if I switch back into Remix, and if I unwrap this side panel again, so if I click on get balance on my proxy, suddenly I will see that this proxy contract holds 98 Ether. If I click in here on balance of the selling escrow contract, I will see that it doesn't have any Ether. And because I am the owner, me as the buyer, I am the owner of my my proxy contract, I can actually call to withdraw all the balance. Just clicked it. So all the balance disappeared and it made it to my wallet. Right now I hold 195 Ether. Okay? So the poor seller got nothing. They actually lost all the Ether that they ever owned, that they ever let go of. I got 100 extra Ether and a free house. That's not a bad deal, right? Okay. So this is how Reentrancy works. We'll switch back to my slides. I have 5 more slides to go through. So for the technical audience in here, I mentioned that in Solidity we have 3 ways of transferring Ether. And if you remember what Nilo was doing before, she was calling this address.transfer method. I replaced it with address.call.value, and there's actually one more called address.send. And all of them transfer Ether between addresses and smart contracts. They differ in a couple of ways. So in Ethereum network, we have concept of something that's called gas. When the transactions are performed and the computations are performed on the Ethereum virtual machine, the people, the miners, the nodes that are performing those transactions, they actually get paid for it. And they get paid for every single instruction that they perform, and they get paid in form of gas. Okay? So the subtle difference between these 3 things is how they operate the gas. So address.transfer has some fixed amount of gas associated to it that is so small that it actually doesn't allow me to do anything in the default fallback function. So it would not allow me to trigger that reentrant loop. It would just say, hey, you didn't give me any gas, I'm not going to do anything. Okay? On the other hand, address.callValue, it will actually give me a lot of gas, all the gas that came in with the transaction itself. So it will start allowing me to nest deeper and deeper and deeper and transfer more and more Ether into my own wallet. Okay? Another thing that happens, oh yeah, we also have address.send, so that one has also just a very small amount of Ether. The other thing that happens is, what happens if there is not enough Ether? So if I'm trying to transfer some amount of Ether, but that Ether is not available. So in case of address.transfer, what happens is throwing an exception, and the state of the whole transaction will be reverted. In address.call.value, it will just return false to you, say, hey, I failed, but the state will not get reverted. And the same thing will happen with address.send. And so I switched that method into this so that I can be showing you how to steal Ether from smart contracts. Nilo had this, which would not allow me to steal Ether, but I can already see that I would actually be able to trigger denial of service attack in your contract using this method. And this is the only one that is the correct one. And which one of these 3 you use, that actually very much depends on the scenario that you are developing for. So you or your developer that is doing the development on your behalf, they have to be very knowledgeable about those minor things. So this was reentrancy. Reentrancy is a type of a known vulnerability in smart contracts and in the Ethereum network. But it's not the only one. Solidity is an amazing language. It's probably the worst programming language I have ever seen. I don't know how about you. But it has many more known exploits. So we have reentrancy, we have something called call to unknown, gasless send, exception disorders, typecast, and keep it secrets, and all of those are just types of attacks that you can conduct on Solidity if your contract is not developed properly. Then on top of that, for every single blockchain that allows you to operate smart contracts, including Ethereum, you will have some sort of attacks that are possible for the execution environment. So we have 3 types of known vulnerabilities for the Ethereum virtual machine itself. And finally, we also have some types of vulnerabilities that the whole blockchain platform is prone to. So there are many and many things that you have to watch out for. I had an example of another attack, but I will skip that one because I think that I'm running slightly over time. But I want to finish with this. So because there are so many things that can actually go wrong, what became sort of customary is for you as a developer who is working on a serious product to acquire something called a security audit. Or on the other side, if you're an investor and if you're investing into something and you really care for your money and you don't just want to forfeit it to some random hacker in the internet, you want your project to have acquired a security audit from somebody. So on this last slide, I would like to tell you what you should be expecting as a developer or you should be looking for as an investor in your security audit. So when I conduct security audits for Quantstamp, I have roughly 6 things that I'm looking for. So in the first step, I want my projects to send me code, and I'm looking whether that code is transparent or not. If you send me some obfuscated spaghetti code and tell me this is absolutely secure, then absolutely I will not believe you. You probably don't even know what kind of stuff is hidden in that spaghetti, and I'm not going to raise my hand and say this is safe. So that's the first thing. I'm looking for transparency, cleanliness of the code, some comments, documentation, everything should be up to par. It should be visible that this is a serious project. The second thing that I want is that the code uses up-to-date language. So I will very, very quickly switch back to Remix and show you this. So up here, at the first line of the code, we actually have the version of Solidity specified. And this one that Nilo sent me earlier this week, it specifies the minimum version of Solidity as 4.21. Right now, with nightly builds, we're actually at 4.25. I would never let that pass. Second thing, there are many constructs in this code that actually were replaced. The functions send and transfer themselves, they were actually added to Solidity a little bit later because it showed that that call function, it's not very secure. So the language itself evolves, it contains many new constructs, and as an auditor, I'm looking for those constructs being used. And on top of that, our friends from Consensus, they define some sort of best practices for coding in Solidity that allow you to avoid all of these vulnerabilities. So I'm looking that those best practices are maintained as well. When somebody sends me a project for conducting an audit, I usually ask for a test suite to be delivered with it as well. And with the test suite, we measure something that is called the test coverage. So test coverage, it just defines, or tests, they define a bunch of scenarios, and those scenarios will be executed upon of your smart contract. Okay? Now, with test coverage, we simply execute all those tests, and we have a look how many lines of code or statements that are present in your code were executed versus how many lines of code are present in your smart contract in total, or statements are present in total. And we get some sort of percentage, and we want to get as close to 100 as possible. Now, the fact that you have executed a line of code, it actually doesn't mean that you have executed that line of code in a meaningful way that tests something. So we actually also look at those tests, and we make sure that the test that you are submitting makes sense. Okay? And that they actually test the edge cases and all the weird scenarios, that it's not just a bunch of ideal outcomes. And then there's the fun that starts. So we know about a bunch of vulnerabilities that were described in the past, that were used in the past to steal Ether. So we verify that none of those known vulnerabilities are actually present in the code. And we have some automated tools that help us a little bit. So we execute a bunch of tools, and they point us to little things. But there are some things that cannot be discovered using automated tools. So they actually require human eye and a little bit of a brain. All those automated tools, they also have lots of problems. They actually very often report something that is called a false positive. So they tell you, here is an issue, but it's actually not an issue. So we have a look at everything that is reported, and we double check that the output that we are getting is legit. And those are the generic known vulnerabilities that kind of you can expect to find in any kind of project. But then comes the part that is domain specific. So many smart contracts, they are created with the intention of releasing your own cryptocurrency, your own digital token for something, right? And those are usually fairly simple. It's like 200 lines of code. It's easy. But then there are those big ones where you have protocols for cryptocurrency exchanges and voting systems and various things, probably like the DAO was. And those, they have many more problems that relate to the particular scenario where those smart contracts are used. So we have to dig through that, and we have to make sure that those scenarios are not exposing some unknown vulnerabilities, and that actually requires a lot of training. Finally, in the last point, we look at the documentation and we make sure that the project that was submitted to us and that has some implementation of some specifications in it, that it actually implements the specifications that were specified. Because if I'm a developer and I'm telling you, I'm a developer and I'm in human language telling you, I have implemented a smart contract that does that and that and that and that and that, then you as an investor or user of that smart contract, you have to be confident that this is exactly what that smart contract does, right? So for that, various projects are publishing something that is called white papers and yellow papers, and they describe all those nice things that they are actually doing, but nobody actually tells you whether they are really doing them or whether they, purposefully or not purposefully, or whether they just implemented something else in their smart contract. So we look at those and we compare it to the actual implementation and say, good or not good. And if all of that is good, or if some of this is not good, we actually do it either way, we compile all the findings into a report and we give it to the client. That being you, the developer, you, the investor, or in some cases, when the client is comfortable with it, we make it public and say, those are the results, those are the findings, this is what we recommend that gets fixed, that is absolutely unsecure and that has to get fixed, or everything is good. Okay? The last thing, as a senior software researcher in QuantStem, I work on something that is called QuantStem Audit Protocol. So in QuantStem, we are actually trying to automate as many of these steps as possible. And that's the last thing that I'm going to say. Thank you for your attention, and please feel free to have questions.
I know that it was blocked for about 50 or more years, and many people couldn't get past this problem, but Martin and his team were actually able to advance this problem, and because of that, Martin won Paper of the Year for PhD. He's a University of Waterloo graduate, and very proud to have him as part of our team. And this is who we have auditing the codes of smart contracts. So, yes, the best, most secure people and the brightest people we're hoping that can make this technology work and get it going. But for the rest of us, the more business-sided, or the community side, the academic side, we're going to step out of the coding environment. I know that was a little bit dense for the lighter side of us, but hopefully it gave you some glimpse of what that world looks like and how it operates and why it's important, and just even how easy it is to lose all your money and why these things are important and we need to look after them. So switching gears, next up is a good friend of mine, Z Tang, and he started a company called Blitz Crypto, and his focus is on community management. And I myself am a community manager, and this is a job title that probably didn't exist maybe 5 years ago or 10 years ago, but it's become really important in specifically the crypto and the blockchain industry is really propelling this profession. And there's a lot of good reason behind this. This is a different type of industry than we've seen in traditional investment industries, and the community behind it is really important. And Z is very experienced in building successful communities behind blockchain and crypto companies, and I'm going to let Z take it away and tell you a little bit more about what he does.